Good morning, good afternoon, wherever you are in your day. More mathematics with Mr. Harris, Pulaski High School, Informal Geometry, Algebra 1. So without further ado, let's jump into the lesson. All right, keep doing that math. Your future earnings will thank you. Do what you can. Crazy time, unprecedented, a lot of challenges. So no need to stress yourself out any more than where you're currently at. Control what you can control. So do whatever works for you, what part of it you can. Encourage you to get in a routine. Keep chipping away. That's what we're doing around here. So yeah, half-hour day. If you get stuck, reach out. Zooming with a student later today. So happy to do that. Just send an email back to another student with some feedback on some paperwork they did. So kind of whatever is working for you, and make sure you're working. So that's pretty essential part of the puzzle. Try and get 75%. And if you get stuck, feel free to try the new stuff. For me, man, I would be all about that in high school. Like, oh, I can start doing the other stuff. That would put me ahead when we actually got in the classroom. So, not to go full boomer on you, but we really didn't have that opportunity back in the day. So, yeah, take advantage of it. Preview next year's course, work on your stuff in some kind of routine. Don't stress yourself out. Do what you can and reach out if you need help. All right, so let's jump into some examples. So distance formula, distance between 2 points. Here's the line here. So really, this is just reworked Pythagorean theorem, okay? So you've got a line here. We need to figure out how long it is. So we basically make a right triangle out of it. And then once we have a right triangle, we can use Pythagorean. So this leg would be 5, and this leg would be 5. And C is the distance we're trying to find. It's the hypotenuse. Obviously, across from the right angle, obviously the longest side. A and B, as long as they're legs, doesn't matter which one's A and which one's B. So you just plug and chug. 5 squared plus 5 squared is C squared. 25 plus 25 squared. 50 is C squared. So C would be the square root of 50. You can put it in your calculator. You can get a decimal approximation, which we did here. I also showed you how to simplify that radical or root. So you look for perfect squares inside 50. Biggest perfect square inside 50 is 25. Square root of 25 is 5. And root 2. 2 does not have any perfect squares in it. Perfect squares other than 1, right? Everything has 1. Perfect squares 1, 4, 9, 16, 25, 36, 49, etc. Okay, so that's an example of using Pythagorean to find the distance, showing you how to approximate it with a decimal, throw it in your calculator, or getting an exact answer by simplifying the radical. All right, hope that helps. Let's look at another example. So here's another example given points, okay? And here's the formula, which, some students like pictures, some students like the formula, whatever works. You could have done the other one with this formula by identifying the points and plugging and chugging. Yeah, I mean, it just kind of depends what you're given for me, as to what works better. If it's nice and simple, like the last one we saw, I like to use Pythagorean. If you're just given the points, usually this is fine. But whatever, there's some nuance there. So distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. I just x1, y1, 6 and 4, x2, y2, -5 and -1. So then it's just plug and chug. Y2 is -5, y1 is 6, minus 6. Y2 is -1, and y1 is the 4, and there's a negative there. So simplify what's in the parenthesis first, -11 and -5. Square both those things, they're going to be positive. 121 plus 146. And then the exact answer is the square root of 146. You could plug that in a calculator for an approximate answer. These problems call for an exact answer. You can't simplify that because there's no perfect squares that go into 146. 4 doesn't, 9 doesn't, 16, 25, 36, 49, 64, 81, 100, 21, 144. None of those go in equally. So yeah, there's an example of how to do distance with the formula. I will do a count example live for you. All right, so what's the distance between these guys? So it's drawing out x1, y1, x2, y2. Okay, so then it's just plug and chug. Let's get a radical. So this is going to be the square root of y2 minus y1. Excuse me, I think on the other formula I did x first. So I'll do that here. It doesn't really matter. -9, as long as you combine the x's and the 1. -9 minus -5 is going to be +5. And we'll square that eventually. Plus y2 minus -5 would be +5. Okay, so x2 minus x1 changes to a plus y2 -2 minus y1 changes to a plus. So then next line would be what is that, -4. Plus 3 squared. That's positive, so I'm not worrying about the parentheses. Let's draw our little radical. We still have working here. And then 4 squared, 16. Plus 9. So the root. And then that's going to be the square root of that. Which of course is, so there you go. There's a live distance example for you. So pause it. rewind it, record it, whatever you want to do with this, and that should help you when you're doing your con. So hope that helps, and please reach out if it doesn't. Brush up on your algebra, try some algebra 2. Just keep getting better every day. If you do that for the long run, you will be on a far better place than where you are right now. So hope that helps, and we'll move forward. Okay, so let's clear those drawings out. All right, so this is a copy of the notes from the hard copy notes. So reducing roots, reducing radicals. There's actually some on the geometry like this, but I'll show you this piece right now. So basically, you're just looking for perfect squares that go into here. So one's always going to work, obviously. It doesn't get us anything, so I just go through them, and it's just number theory, and you just kind of chip away at it, and you'll get better. So does 4 go in? Does 9 go in? Does 16 go in? Does 5 times 5, 25 go in? 6 times 6, 36 go in, right? Because then you can break down these perfect squares, okay? I always look for the biggest one, and you can do it with the smaller ones too. There's a little more work you need to do, so whatever works for you, but I tend to look for the bigger ones either way. So square root of 24, 4 and 6 multiply together to get 24, so 4 is a perfect square. So the square root of 4 is 2, and the square root of 6 is the square root of 6. There's no perfect squares that go into 6. 4 would be the only one, of course, again, other than 1. Right, so that is as far down as you can break that one. So here's 45. 4 doesn't go in. 9 does. Let's try the other ones. Does 16? No. 25? No. 36? No. And that's as high as you need to go because 49 is bigger than 45. So 9 root 5, square root of 9 is 3, and root 5 is root 5. There you go. That right here, 4, well, 4 is just 4, and the square root of 36 is 6. So 4 times 6 is 24. Okay. Yeah, so there's that little nuance here. I mean, look for perfect squares that go into 30. 4 doesn't, 16 doesn't, 25 doesn't, 36 is too big. So then you look for common multiples, right? Because 30 breaks into the square root of 5 and the square root of 6. And you have the square root of 5 here. Let's go ahead and do that. And you'll see, if you don't already, why shortly. So break that into root, that's already root 5. And then 30 is root 6, root 5. And then you're multiplying, so you can change the order. So now you've got root 5 times root 5 times root 6. Just those things around, multiplying any order you want. And then root 5 times root 5 is, another way to write that is root 5 squared. And if you take the square root of something and square it, you get what was originally under the radical. So if we take the square root of 5 and square it, we get 5. And the square root of 6 is just the square root of 6 because you can't find any perfect squares that go into 6 other than 1. So that's how you would approach something like that. Okay. Multiple ways to do number 6. I just showed you one way. I showed you every step, so don't necessarily have to do all these steps, but just wanted to be as transparent as I could with this example. So don't let all the writing scare you. There's more than one way to skin a cat, so more than one way to do this problem. So 3 times root 6 times 5, and I went ahead and broke that into 4 and 2 because 4 is perfect square. So started simplifying right away. So 3 times root 6 times 5 times 2, square root of 4 is 2. So that's the only change in this time. Square root of 4 is 2. And then what did I do? It looks like I did a little rearranging. There's only multiplication going on here, so we can move multiplication in any order we want. 3 times 2 times 1 is the same as 1 times 2 times 3. Doesn't matter. So 3 times 5 times 2, just put the whole numbers together, and then root 6 times root 2. So simplified 3 times 5 times 2, 30, and left that alone. Root 6 times root 2. Oops. So there we are there. Multiplied the 6 and the 2 together to get root 12 because I knew that a 4 went in there. And you can experiment in math just like you experiment in other things. That is healthy practice, taking appropriate risks. So 30 times 12, root 12, because root 12, 4 and 3, right? And 4 is a perfect square. So now I've got 30 root 12, 30 times root 4 root 3, 30 times 2 is 60. So 60 root 3. So that's how, oh, I gotta help my daughter get in the toilet. So 60 root 3, 4. Thanks, Dad. Okay, so that's an example there. I'll do one live from Khan, but those are all up there. You can look at them, you can study them, you can record them, or you can reuse them. So whatever helps you get this material. All right, so let's go to the last. All right, so here's one right from Khan. Move all perfect squares from inside the square root. So I think I'll show you a couple different ways to do this. So kind of the basic way is 9. It's pretty obvious that 9 goes into 180, right? So 180 is square root of 9 and the square root of 20. Now there's another perfect square here, which is 4. You see that pretty easily. So this is square root of 9, square root of 4, square root of 5. Okay, that is all broken down here. There's all times inside. Now, I know that 9 times 4 is 36. So the other way to do this is to see if 36 goes into 180. So I used calculator and 36 times 5 goes in. So this is the whole, like, you can do it with the smaller perfect squares. You just might have to do it twice or 3 times, whatever, until you can reduce it all the way. If you find the biggest perfect square that goes in, you might only have to split it once. Whatever, I mean, different ways to do things. So if you're doing this way, it's just 6 root 5. And if you do it this way, 3 times 2 root 5. And 3 times 2 is obviously 6 root 5. So same thing, either way, right? More than one way to skin a cat, as an old math teacher that I had and enjoyed used to tell me. Or, want to be more gentle, more than one way to climb the mountain. I don't want you guys to get upset. So either way, whatever works, 2 ways to solve the problem, whatever helps you the best. So there's some more. I'll stop the share. So that's the way, 2 ways to do that. Keep chipping away, keep doing what you're doing. Sending all my best to all of you, hoping for health, hoping for peace, hoping for safety, and yeah, hoping for warm weather too. So all my best to you guys. Be well, take care, and I'll post some more of these and some more problems as time moves forward. All right. Talk to you soon.